Suppose a viewing screen is separated from a double slit by 4.8 meters, which is R equals 4.80 meters. The distance between the two slits is given to be 0.03 millimeters. Let's be careful with these units when we're solving it. And monochromatic light is directed towards the double slit and forms an interference pattern on the screen. Well, the first dark fringe is 4.50 centimeters from the center of the line on the screen. What does it mean? It means the first dark fringe, which is this guy right here, that tells us it's m equals 0. And from the central line is this guy right here. So we want to find out this distance, which means y m dark, we say. And in our case, we will have y, the 0th, m equals 0, which is the first dark fringe. And let's put a dark here, equals 4.50 centimeters. Now we want to find out first what is the wavelength of that light. Second, we want to find out what would be the distance between two adjacent bright fringes. Okay, well, let's try to understand what does it mean. So let's say we have a fringe m, and the adjacent one will be m plus 1, the bright fringe. So then the position of the mth bright fringe will be ym, and then position for the m plus 1th bright fringe will be ym plus 1. So we want to find out the difference, the distance between them. So the distance between them will be the difference between their positions. So in other words, we're looking for ym plus 1 minus ym. That is question mark. So for the first part of this problem, we know that for the dark fringes, y dark, the position, can be found as r m plus 1/2 lambda over d. From here, we can solve for lambda, where lambda equals y dark times d divided by m plus 1/2 and r. Now all we need to do, plug in the numbers. So for the position for the dark fringe, the first one is a 4.50 centimeters, and we gotta convert it to meters. So I'm gonna write 4.50 times 10 to the negative 2 meters times the distance between the slits is 0.03 millimeters. Converted to meter, that will become of 3.00 times 10 to the negative 5 meters divided by, so m is a 0 because it's the first dark fringe, plus 1/2 times the r, which is 4.80 meters. We're punching this into our calculator. The result will give us 5.62 times 10 to the negative 7 meters, or that is a 562 nanometers. Now for part B, we want to calculate the distance between adjacent bright fringes, and that would be ym plus 1 minus ym, and we will use the expression for the bright fringe. We have found the position of a bright fringe earlier. We found that ym equals m lambda r over d. So I can use this expression and find the difference between the two adjacent bright fringes. So I would write m plus 1 lambda r over d minus m lambda r over d, which will give me just lambda r over d, and that will equal, we just need to plug in the numbers. So let's use the meters. 5.62 times 10 to the negative 7 meters. The r is 4.80 meters divided by 3 times 10 to the negative 5 meters. And punch this into a calculator, we'll get 9.00 times 10 to the negative 2 meters, which is 9.00 centimeters. Thanks for watching. Stay tuned for more examples.